Good morning all. Here's a Yaskawa Servopack SGDB-20VD. And we're going to test L1, L2, L3 to plus bus and bus ground. And then we're going to test U, V, and W from plus bus to bus ground. So put our black lead first on plus bus. We'll go L1, L1 to plus bus. We have a diode voltage drop 0.530. L2 to plus bus 0.533. L3 to plus bus 0.525. Now let's put our red lead on bus minus. With our black lead still on plus bus, and we have 0.414 volt diode drop from plus bus to bus ground. Now we'll go U, V, and W. That's our motor output. Plus bus to U, 0.417. Plus bus to V. Oh, there, look at that. 0.006 volt diode drop. That's a short circuit. Let's check W to plus bus. 0.414. So far, looks like that IGBT is shorted from plus bus to V. Now put your red lead on bus ground. Let's do the same. Black lead on L1, 0.533 volt diode drop. L2, 0.528 volt diode drop. L3 to bus ground, 0.519 volt diode drop. So the three-phase bridge is good, but the IGBT is bad. Let's go ahead, put our red lead back on bus ground, and let's check U, V, and W to bus ground. We already know it's shorted from bus plus to V. There's U to bus ground, 0.408 volt diode drop. V to bus ground, the same, 0.408 volt diode drop. Black lead on W, red lead on bus ground, 0.411 volt diode drop. We have to go inside. I hear Tommy over there. Maybe Tommy can come and help us take this drive apart. We have to go in and get a part number for that IGBT power module. Hey, come here, Tom. I'm over here. Tommy's going to come over and help us take this apart. Come on, Tommy. Come on, where are you at? There he is. There he is. Come on. Did you get some breakfast? Tom can't figure out if he wants to go outside or stay indoors. I got the shop door open for him, and he's going in and out. Okay, let's take our little drive apart. Don't bump into the tripod, Tom. You'll knock the camera over. Somebody's done some work up here. Somebody's been in this drive already. They recapped it. They had tall caps. They had to turn them on their sides so that they could put the lid back on. Yeah, pretty smart. Whoever done that. No, Tom's bumping the tripod. Yeah, Tom. Hold on. Don't bump the tripod. I'm going to have to turn the camera off. We'll be back in a little bit. Somebody's replaced this capacitor right here. Normally, these capacitors are black, not blue. Come on. That clip doesn't want to come undone. Okay, I have to undo these two screws here. Okay, remember when we go to hook this back up, that red comes up through the left side, that black comes up through the right side. You don't want to get those backwards. Get that bus capacitor backwards and we'll have us a good bang. Come on, Tom. What are you doing over there? Where you at? Come on, you're supposed to be helping me. Here's the cooling fan and the motor or the heat sink thermal connections right here. Undo those two, and we're going to take this top board off of here that sits over the IGBT. We have these screws right here to take off. Real quick, let's check that fuse, see if it's still good. Alright, that fuse is still good. 0.2 ohms. Oh, they put that one in tight. That one undone. Now undo this one over here. We should be ready to come off. There we go. Now there's some stake connectors over here that plug in to these two connectors right here. There we go. We are downstairs. Let's move these things out of the way. There's our IGBT right there. Part number 7MBI75N-060, manufactured by Fuji Electric. These two wires right here go to the regenerative braking resistor. Let's measure that. Make sure that's still good. Set our meter to ohms. And we have 24.9 ohms. That resistor is still good. Let's take this apart. here's the three-phase bridge rectifier. You have to undo those screws that hold it to the heat sink assembly. These are the standoffs that take UV and W up to the upper level board. Now I'm thinking that should be it. There we go. Oh, one more screw. Missed that one. Oh man, torqued that one down to 5,000 foot-pounds. Okay. There we are. Okay. The board don't look damaged. That's a good sign. We'll still run our meter through the output side of these driver ICs. Okay. There's the three-phase bridge. It's also made by Fuji Electric. Part number 6RI30E-080. Set this off to the side. Let's check the IGBT out of the circuit. Here's the P terminal. Here's the B terminal. Here's the N terminal. And here is U, V, and W. Got my meter set to diode test mode. We're going to go put the black lead on the P terminal, and we're going to go to V. Yep. That's a dead short. Here's U, 0.411 volt diode drop. Here's W, 0.409 volt diode drop. Here's P with red lead on N, 0.408 volt diode drop. Here's P to the brake terminal, 0.465 volt diode drop. Now let's look. It's on the high side, and this is probably the gate emitter for V. Let's look, see if it's shorted back up into oh, my phone's ringing. Who could that be? We're gonna have to check. We're gonna have to check that gate circuit. Hold on. Let's let that phone stop ringing. There we go. Okay, now we can get back to work. So here's P to this pin. We have 0.409 volt diode drop. Here's P to this pin, We have a short circuit. Here's P to this pin, 0.411 volt diode drop. Let's go to the other pins and see what we get. Yeah, this is shorted. We're going to have to go back up into the firing board and check that firing circuit to make sure it's okay. Yeah, this gate firing channel is also shorted. Oh, we got our work cut out for us on this drive. First, we have to get this IGBT power module. Pin 1 and 2, we have 4.647 ohms. Here's the gate emitter of the shorted firing channel. And we have a good 4.685 ohms, so this firing channel is probably good. We'll go through and we'll check all the resistors and diodes and capacitors in this PC928 gate driver IC. So let's go here. 4.685 across that resistor. There's 2.181. That's probably a 2.2 kilo ohm resistor. That's good. Let's check this capacitor. 40.8 kilo ohms. Let's go across this capacitor. 41 kilo ohms. Here's another capacitor. 40.3 kilo ohms. Let's check the diodes. Alright, that diode's good. 0.697 volt diode drop. Let's check this last diode. 0.590 volt diode drop. So those devices are good. Now we're going to get on ground of this gate driver optocoupler. We're going to go through and check the output side. 0.692. 0.590. This is ground. That's good. 0.647. 0.591. And the last one on the output side, 0.590 volt diode drop. So the fire channel survived. That's good. So all we'll have to do is swap out that IGBT power module and put it all back together. Well, that'll be for another day because we got to wait on the part.